Hi guys, I hope you're good since the last video. So in the previous video, we've seen the structured output. We went for the first way, which was very consistent, but I wanted to come back to it just to rectify something. As I said, it was the perfect output, but we can see that the result is not perfect. We don't get the right amount, while the description of the calculation was right and the initial numbers were identified, captured, but we will be going for this way because it was the more consistent one. So as I said in the introduction of the previous video, is that we're using small LLMs. They're not perfect, but we can find the best system using those. And we're going to be using in this video this structure output the first way, even if the result here is not perfect. Okay, so in this video, we're going to be using multi-graph, multi-agent system. We're going to be chaining those graphs. So it's going to be combining everything that we've seen in the different experiments. And here we're going to be experimenting using one graph and after another in a business logic application. So this is the architecture that we're going to be explaining more into the details. There will be an app business logic in the middle, handling all those graphs. So initially what we've seen in the previous videos is more what are the components. We had a custom chunking method to store those documents. We're caching using UID and the content. We have a Postgres table and we have a PG vector collection. So that's the configuration for the database. User query goes to the embedding retriever. That's what we've tried to do. But we just did the embedding side. We're gonna be chaining everything here and adding a caching system. So with a retrieval, fetching from the database or from the cache, and creating a response from that. Here we're going to be trying to create a report. The Redis cache, there will be semantic match and exact match. We're going to be using hashing system and also embeddings. So now let's go into the context of our video. This application here, we may start maybe with the user, just to explain it before starting everything. So we have the picture of it. User is querying URL, PDF or text, goes through the application business logic, which is the center, and there's another center which is the environment variable center or the configuration center. And we have this chaining of graphs around it. The primary graph to analyze the query. So have the component of a graph, nodes, edges, and tools. We have environment variables. The graph sends to the dynamic environment variables. And the next graph is going to be using those vars in order to start his workflow. And the business logic is going to be managing how the workflow passes from one graph to another with some conditions. We have a retrieval graph and we have the report graph, specialized agent to make the reports. And after we get this report document, and the user is able to see the report document. We're going to be working on the terminal on the background, but you can use a UI if you want to for that. So here in the databases, we have a Redis cache, matching the query in hash or vector, and we have the Postgres database, which has the collections of vectors. And here we store in the database and we embed in PG vector. The retrieval agent will be retrieving and will be also caching the responses into the Redis cache. So here the retrieval agent and the report agent are going to be using the structured outputs. So there will be an agent using a tool, and we want this structure output in order to make this report at the end. So you see the configuration here. We have a kind of a circular configuration. There might be some issues with this configuration. That's why we're using this application business logic to handle those issues. So maybe we can draw here what kind of issues that we can find. If we just change the graphs, you can have, let's say, those points are the different agents. On the circle, it's the link between those agents. So the different graphs, so each point it's a combination of nodes, edges. So here, if you get an issue between two graphs, two agents, or inside any agent, the application just is going to be just crashing. So your logic is going to be dying somewhere in the application. So you need to handle that. That's why we're using this business logic middleware application, let's say. And here would be just to draw this star. So I took this from maybe networking, and we can use the same logic here. So this is not gonna work. I'm just gonna take just a pen and draw the circle. Get rid of this. So here what we want to show is that using an app business logic as a kind of a middleware, we can maybe provide more solutions. So if it fails between two graphs, you can use another direction, okay, and have some alternatives. If it fails at the agent level, so at this time you can have some different alternatives. So you can also design it this way. So it's not 100% this way that we have designed it, but it's the idea behind it. That's why there is an application business logic, and there is a configuration and environment variable center, and we have the graphs passing. We need just to think about it when we are designing this kind of application at the beginning. So that's why I prefer to start always with a drawing before starting any coding. You see here it works like that. This is like a star, let's say, somehow. And we're going to be working from this app business logic. And we're going to have separate files. So I suggest you also to divide everything, to have a report agent in its own file with all the nodes, the edges and the tools and whatever it needs. Same for the embedding agent, same for the retrieval agent, same for any agent that you're going to make. Make sure that it works as a standalone agent before incorporating, before putting it into your application. And also it's a good way to be able to use the same agent in another application. So at this time you will just build several different agents for different tasks, and you'll be able to reuse those. So here just handle scenarios and possible errors. So this is the component here that we've built. Okay, let's do that quick. All right. So that's the idea behind this little architecture. Have a little break. Please like and subscribe. And let's jump into the next section where we're gonna be first running the code. So let's start here. So we get the same query as in the previous videos. This is the Redis cache from my initial test. I'm just going to show you here the environment variables. And I'm going to get rid of all those dynamic environment variables that are going to be printed. So inside there are the configs, and there will be also the environment variables that are going to be passed from one graph to another. We're going to be building a prompt. So just let me get this prompt here. So that's our prompt. What is responsible for detecting temperature changes in our skin? And here I have the documents. So I have a folder with some different documents. Here we're just going to build the prompt very quickly. So it's not an elaborated prompt, it's just a simple one. And let's see how agents are going to be working with that. So check these documents. And I just give it the path of our document, which is this one here, a small document. So the embedding and the story in the database won't take an hour. So you'll be able to see all in one video. And here we're exploring the cellular. So you'll see the report at the end. We get the response. So what is interesting here is to see the details in what's going on in the workflow. So just let me go here. I'm just going to put the prompt here. It's for me. Keep it in the notes. Let's go. So there'll be a lot of logs printing. But that's a good way to see what's going on. And also to have the ability to show you actually. You can use logging system. So we might use in the future LangFuse. But here I'm just going to use the terminal in this video. So now it's going to start embedding the documents. So we got the question if we want to store the document again, because the document has been saved already. But here it's going to be starting the embedding process. We're going to go through it while the embedding is processing. So this is the first graph, the primary graph, get user input. Just get the raw input. That's the primary graph running. So it's going to be reformulating this query. It's going to be trying to detect any document in that query. So PDF data. So it has detected the PDF, starting to chunk the document, which is the field temperature document. So we get those objects, those dictionaries being created with sections. So this is an intermediary step where we're going to combine some of those fields to make this data frame, having text, section, documents. So here it won't be perfect, but after that we're using LLM again to get a summarization of those fields, combining those fields to get titles also for each group of dictionaries that are going to be in our chunk. So here we can see that the chunk is not perfectly respected, but it's very close to the number. So here we get the summary that we are going to put in the data frame. And it's going to be saved into the database in the right. Okay, here is the data frame, the final data frame, having this time different fields: ID, UID, document name, the title, and the content, and if it has been retrieved or not. So after that, it's going to be serialized into a packet file. So the data frame from query. We get this packet file. We save it in a folder. There is an LangGraph node that I added, which has a transition. And after we start a second graph. So starting the embedding graph, which is going to get the user input, which is the previous graph output. And here we're using environment variables for that. We're going to deserialize it. So we get this data frame back to its original state. And we're going to put it into the database. We get the question here, document already present. You want to update it? I say yes, so that you can see all the nodes present in the graph, because I've been using it before. So we delete the file because we don't need it anymore. The intermediary file that we use here, the packet one, now is deleted. Store data frame in database, successfully stored. And here is the embedding starting, where we do custom documents, UID, the content. So only UID content per document, and depending on the chunk size, it's going to be having 1 or 2 documents per chunk, per embedding. And here you can see the embeddings are still going on, but we're almost there. Just wait a few seconds. It's not going to be long. So in the meantime, what we can do, we can maybe explore our database in PostgreSQL and see the table. So let's connect to it. Let's just select all the fields from the database, because it's already processed and saved here. And we get the fields with the documents, the title, and the content. And here if it has been retrieved or not. So as I ran it before, some has been retrieved. Okay. It looks a bit messy like that, but it's well structured into the database. We can also maybe check the Redis embeddings, if you have some. So the embeddings, there's 2 different embeddings. The hash of the query, so we're going to use it as a key. That's how we can retrieve, see the content of what has been found into the database, or the vector. So here we have the where is it? The response, and we have also the embeddings. So we just use here a dictionary. So this is for the semantic search into the Redis database. So the little cache system that we have on the side. Okay. Are we good? So we got all those embeddings. Might have 11 or 10 of those. Yeah. Here we go. So now that we're done with the embeddings, we're gonna see the graph just keep going, printing some, so it's gonna be pretty quick to the end now. And it's done. So the blocking part are the embeddings. So now just let's check what's happened. So chunk and embed from a database. So it's a successful embedding, has been done properly. That was the last chunk. The LangGraph node is going to relay this success message. Cool. But we're going to use environment variables for that. And after we start the retrieval graph, which is another agent specialized in retrieving. So the reformulated query is going to get it from the environment variables. What detects temperature changes in the skin? This has been fetched from the cache. So it has found the answer through the cache. So here we can see the content, the response, I mean. And here, semantic search in Redis response. So this has been, so the hash didn't work, hasn't been found. That's why I have the alternative of a semantic search, and it has found this one here. While this one here, the hash, using just the hash of the query, it didn't find any match. So handle query by calling cache, then vector if it fails. So that's what we have used after the embedding. After we got a message here, success semantic. So it means that it has been retrieved. We use a node called answer user, but actually we're not talking to the user. This is for us. First graph, and we get the semantic here. We just build a response having the answer and having the query reformulated. So after that, we start the report creation graph. We have set into the environment variables the retrieve the answer. We fetch the answer and query reformulated. So we get both here, retrieved answer, and in the first graph here we get the message reformulated. So what detects temperature changes in the skin? So this time we can start building up and making our reports. So internet agent is going to fetch from the internet using the search tool. Here is going to be choosing that tool, using this query, TRP ion channels, and thermoceptors in skin temperature. And after here, the tool search node is going to be answering to the question using the structure of the tool schema. So tool has been called. This is just for the logs. After here, we get the answer from the internet, but using structured output. We wanted a title, we want advice, we want the answer, and we want bullet points. So this is just 4 different fields, very simple ones. Answer with report. So at this time, the report is going to be saved into a file. Here we go. We're going to the report folder. I'm just going to reload this to get the latest report that we got. Here we go. Creditizens answer. How do we perceive temperature changes in the skin? When exposed to the temperature changes, the skin relies on specialized receptors called thermoceptors to detect and convert thermal energy into electrical signals. So after it keeps its good report. To better understand this process, consider the following advice. Familiarize yourself with the two types of thermoceptors, cold and warm thermoceptors. After it talks about the transition receptor potential, ion channels which are sensitive to temperature and chemical heat sources. Understand the role of nerves, cells, and ion channels in temperature sensation. Explore how the brain intercepts electrical signals for thermoceptors to create the sensation of temperature. The temperature changes in the skin are detected through specialized receptors called thermoceptors, which are free nerves ending, FNE, located in the dermis and extend in the middle epidermis. Okay, these receptors are not enclosed within a membrane, allowing them to directly interact with the skin and detect the physical stimuli. There is two types of thermoceptors, cold and warm thermoceptors, which vary in concentration throughout the body. For example, the ears and face have a great concentration of thermoceptors, making them more sensitive to temperature changes. Okay, where are we here? Changes. Thermoceptors convert thermal energy into electrical signals through tangent receptor potential in ion channels. These channels are sensitive to temperature and chemical heat resources, for instance. Those receptors, also known as the warm receptor. Okay, so burning causes this is the chili pepper. The capsaicin binds to the TRPV1 receptor. It triggers an influx of sodium and calcium into nerve cells, initiating the firing of associated nerves. Okay, so once the electrical signals are generated, they are transmitted to the brain via the spinal cord. The brain intercepts these signals and translates them into sensations of temperature. Prolonged or recurring exposure to cold or menthol can lead to sensory adaptation, which arise from reduced TRPM8 activity. This desensitization of TRPM8 substantially shapes our perception of cold. So after here we get the bullet points. Thermoceptors are free nerves endings located in the dermis that extend to the mid-epidermis. There's two types of thermoceptor, cold and warm. Thermoceptors vary in concentration throughout the body. Transition receptor potential ion channels convert thermal energy into electrical signals. TRPV1s or warm receptors are responsible for the burning sensation caused by capsaicin in chili peppers, and the TRPM8 receptors conduct messages about cold stimuli. When cooling agents like menthol bind to them, prolonged or recurring exposure to cold or menthol can lead to sensory adaptation due to reduced TRPM8 activity. So this is the kind of report that you can get from just a single query, just putting the document in it. So using the embeddings and using internet search, I find it kind of cool. This is pretty nice. So now that we've seen the report, we can maybe go into the details. So let's see the graphs. So that's the primary graph. We start here, get the user input, data from query, and after there are different routes. If there is an error handler, which is going to be handling the errors. Internet search. So if there's no document in the query, it's just going to search the answer to the text. And the intergraph node, just to be the transitions, pass the messages to the next graph. And after we end everything here, so let's go into the code. Primary graph agent. Now we're going to go into the details of the codes. We process the query, data frame from query node. Just going to find where it is. It's in the app utils. So I put all the different functions into one file, which is a separate one. It can be used by all the different agents. And here we get the data frame. After here, we're just gonna stay into the agent graph. Primary graph is gonna have a conditional edge, and depending on the output. So if it is a path, it's gonna go to the intergraph node. If it is here you see data frame, intergraph node, and this one is the path. If we get a query, just a text query, we're just going to use internet search agent. So we just have a question. We didn't put any document or web URL. So this time it's going to be just providing the answer. And for any errors, the error handler is going to be handling those errors and sending it back to the application business logic center. So here we are in the application business logic center. Here I'm using custom state. You don't need to, but I just want to show how it works. So that's where we get the question form. We can build custom states and after use that variable to just start the graph. So let's say in your application, for example, you're using messup, you have those states, so you can use those variables here to start your graph, or has intermediary. So instead of using the environment variables, use the messup states. So here the primary graph is going to be returning embeddings or error. It's going to check if in the environment variables we have saved the path of a Parquet file. If the path is present, we can go to the embedding graph, which is we'll be able to use it. If the path is not present, at this time we are going just to return an error because the job hasn't been done properly. So here is the different configurations that you have in this file. So that's the config and environment variable center, where we have the different chunking size, the different scores, TTL, time to live, or cache. So the query reformulated and everything is going to go into the dynamic side of the file. Just going to be changing it. While here, we're going to capture this packet file path. The primary flow is returning embeddings, so at this time we can start the second graph. So this is simple to understand, but you can put in between any logic in your application. Just going to find the right graph. So this is the graph, the embedding graph. We start, we get the input. Okay, we store data frame, we chunk it. Intergraph, we end it. If there is an error, we return the error. If there is an intersearch to do, we do the intersearch. Embedding graph, let's go into the details of this graph. So when I say graph, just think it's an agent. So different agent, different workflows. We can talk about complex agent because they have different nodes, so different possibilities. So here we store the data frame. We in the conditional edge. If it returns success, if it returns text or if it returns error, it's going to go to different nodes. So error handler, internet search, or process to the chunking and embedding data from the database. So you can see here that in the workflow, we get the document, we put everything in the data frame, we save it in a Packet file. We get the Packet file, we put in the database, and after from the database, we're gonna create those embeddings. In the meantime, the data is being processed, modified, restructured, and summarized, and everything that can happen in between to be able to retrieve those information in an easy way. So that's why we reformulate also the query. So here, store data to data frame, you've seen the function. Now chunking, this is the chunking function. So I'll go through those functions very quickly. We don't need to go into the details because you've seen those in the previous videos, or some of those. You can pause the video still and check the details. And here I just want to show you, where is it? Embedding graph. As I told you, it can return different kind of message. So where is it? Here. So it can return text, for example, to go to the internet search. So if there's no document, error, success. So where do we find those in the code here? Content, and after it has to be a string inside, so I put it like that. Text, error, success. That's how it's going to be able to recognize it. You see here for the chunking, error or success. So very easy. So that's how you can do your conditional edges, trying to detect those messages. And it's all saved into the state of the agent. So start, get user input, store into the data frame, chunk it, internet search, if there is any internet search to do, using the tools. So this is an agent by itself. Okay. Where was it? It's at the text here. So that's the one I showed you now, internet search. Okay. It's good. So we've seen this agent. It's not very complicated. Okay, and after here, the graph nodes, the end, if there is any error, we use the answer user, which is just going to pass to the application business logic, the message, the error message. So here we can see here, we save it into the environment variable and there is success inside it. So if there is success inside it, we save it here, you see, embedding, graph results, query reformulated. And here we go to the retrieval one. So we use those two to do the retrieval process. So the embedding graph is going to return retrieval, or it's going to return error. And now let's see the retrieval agent. So if there is a success in the embedding graph result and the embedding flow is retrieval, we start the retrieval flow. We use the reformulated query as an initial message. So this will be the one that we're gonna fetch the query reformulated as the first node of this agent. Let's go to the function. Very easy, we just get the last message in the state. Now we got it, it's secured. we're going to go to the next node. So the next node here is going to be to handle the query by calling cache. So we're going to use this query to call the cache. If there is nothing in the cache, we're going to call the vector database. If there is nothing in the vector database, we're going to go into an internet search. So that's the workflow here. To just resume what it is, but in the details, you see here we get a success hash if it finds the hash of the query in the cache, success semantic, which is found if the semantic search is successful, or in the vector database, it's going to be going to retrieve if the cache fails. If the vector database fails, it's going to do an internet search. So let's go into that graph, which is this one. Start, fetch query, handle it, if it is in the cache or not. So if we don't find anything, we just do an internet search. If there is an error handler. Otherwise, we just going to use the answer user. I didn't use any internode field here because we're building the report just after, using the environment variables basically. So nothing in the cache or the vector database here. So you can see here my naming of the function and the variables. It's very explanatory. So the code becomes more like reading a text than just trying to understand something which is not well defined. So the tool has been called. We just check if the tool has been called. We check also if it is not empty, because we never know. So we do a double check here. And the query is going to change depending on that. So if the tool has been called, we can get this internet search result because we got it. If the tool hasn't been called at this time, the query is going to be just the reformulated query for an internet search. Because here what happened here, we're going to do the retrieval, but internet search is going to be used 100%. So it's not an alternative for any failure. So here we're going to use it to build a stronger report. So we want to get some information from the internet. We use here a prompt template. So we just use the template part, but it's good to have the prompts also separated in a field. So that's where we're going to use the structured output. I just show you here that I have a special script for the structured output. We have the title, the advice, the answer, and the bullet points. So that's the structure that we want. Create a detailed professional report using Markdown. And here we create a function doing everything, calling the LLM, taking in the structured output class so that we can reuse it with some of the structured output, the query that we're building. So this is the query that we have here, depending on the tool call or not, and the prompt template part. So for the prompt template part, I'm going to show you the prompt template. So here I just call it structured output report. So same for the prompt, you give it a good name so you can use the right prompt. And here we go into the prompts, we open the prompts file, script, and we go down there and we have here structured output reports. So you keep it like a dictionary like that. So if you want to add human or AI fields, you can add those. So format with instruction and query will be injected. Format instruction, as you've seen in the previous video, using the first way that we have chosen. And the prompt template where we're going to inject the query. And the model here is going to be using the parser, which is the Pydantic output parser, which is aware of the structured class, the Pydantic object. Okay? Which is here, structured class. We're going to pass in the function. And the query here is going to be used in the invoke. So that is going to be injected into the prompt. And what we want here, just let me go to the retrieval. You see we pass the structured output system template. So from the prompt here we get the system template. So that's all we want for that. It can be more sophisticated with human and AI also. But here we just need the system one. We work internally and we get this response dictionary. So we get the response. That's what is good with the structured output. Response title, response advice, response answer and bullet points. So we can use the dot way to get those fields, like if it was a dictionary. We get the response dict. And here we build our report. We're just going to write the file. We get the report path from our config center. So here we get the report path. So all those configurations, you have to change them only in one file. It makes it easy for the application. And here we build just writing into the file different sections of the report. And after we save the report using reports here into the environment variables, report graph result. Call it a success. And we save it there. So here, what happened in the retrieval graph is that we have a workflow to create a report. That's what I showed you here. So from the internet search, so now we're going to see the normal workflow, which is going to be using the other agent, the next agent. So those are the retrieval results. So in case we retrieve something into the database, at this time, we don't need to do the internet search now, because we need to pass it to the next agent. So we have retrieved something in the cache. And we're going to return the success that it has been retrieved. So it's going to be returning report or error. Okay, so let me find the file. It's here. Okay. So the report part is going to fetch the retrieval answer, if it is a report, and the success in the retrieval graph result, which is the environment variable. We're going to split it and get just a retrieval result. That's what we want. So we're going to be getting it from here, the environment variable. You see here we have the success on those 2 points. Where is it? Retrieval result here. Okay. So we're going to be splitting in that. It's going to be a list. So let's see the report graph agent now into the details. We're going to put this retrieval graph result as a first input into the graph. Let me show you the graph, which is a bit more straightforward. Fetch the answer on the query reformulated. Internet search, tool search node, and we answer with the report. So we fetch the answer, query on the query reformulated. So retrieval result, we split on success, we get 1, or if you want, you can just get the previous message. So there's different ways to do it. There's not only one way. Choose the one that you prefer, or you put in the environment variable and you get it from the environment variables, or you fetch it in your application business logic center, as I did here also. So I'll show you the 2 different ways. Well, here I'm going to be just fetching from the environment variable. The query reformulated is also present in the environment variables. This we did save it from the first agent. And after you can just JSON dumps because it has to be a string in the content of the AI, and you can put your dictionary of the retrieved answer to be able to do the internet search. Okay, so here we're using the same system to make a report as the one that we used before. It's going to return success or an error message to the application business center. Okay, and after, at the end, you get the report, as you've seen before. So this can be made more complicated if you want to, but at least you get the different components and you understand how it works, how you can chain different graphs. I just want to talk also about the running the graph agent as a standalone. So put the graphs, the agent in a separate files, use if name equal main, put some dummy data, and run those graphs independently. It's very important to do that so that you can reuse those graphs in other workflows. After talking about testing your multiple graphs separately, we can transition also to the similarity score in vector retrieval. I use low values for the retrieval score, initially to make sure all works fine, before increasing it incrementally to the right levels. You have to find the balance between the model level you're using. Like here we use Mixtral 7B, it's a small model. The embedding dimension, like here we use 4096 dimensions because we're using Oyama embeddings, and the satisfaction about the retrieved quality or the relevance of the data. So it's a balance between those three. In this configuration, I found that 0.7 was too high and 0.6 or 0.61 was better. But if I was to use OpenAI or Anthropic models, I would probably raise it to 0.8 or 0.9, even if their embedding models have a lower dimension. But when I test, I usually use 0.5 or 0.4. Here in this video, I used 0.4 just to see the flow of caching, retrieval, everything was fine. Or after you move it up incrementally, just to make sure that you have the right balance in your application. So just work with data first and then go into the details probably. That's what I believe can be done at the moment. All right, so I hope that you like this video. I'm going to stop here. Please like and subscribe, and see you next time.